Good morning, everyone, and welcome to the Fiber Broadband Association's Fiber for Breakfast. We're now on our 13th episode of 2022. But before we kick off, I'd like to thank our sponsors for Fiber for Breakfast, including our platinum sponsor, Broadband.money, our gold sponsors, Jonard Tools, Millennium, and MyBundle.tv, and our silver sponsor, STL. Last Wednesday, we kicked off our series of regional Fiber Connect workshops that began in Baton Rouge. Despite severe weather and tornadoes, I don't know, locusts may have came in, I don't know, the night before, but we ended up with record attendance and a great fiber workshop. I'd like to thank Governor John Bell Edwards and Vineet Iyengar, the Louisiana State Broadband Director, for all their tremendous support for this event. Our next stop is going to be at the Omni in Providence, Rhode Island on April 19th. We invited the Secretary of Commerce, Gina Raimondo, and her Chief of Staff, Kevin Gallagher, to join us back in her home state. As many of you know, Secretary Raimondo was the first female governor of Rhode Island from 2015 to 2021. We'll also hear from State Representative Deb Ruggiero, who's an outspoken advocate for fiber. We have a great lineup of speakers. We also expect to have a broad audience from community leaders from the surrounding states. So please join us in Rhode Island, April 19th. After Rhode Island, we're going to be in Nashville, June 12th to 15th for Fiber Connect 2022. And last week at Fiber for Breakfast, you heard from our conference chair, JJ Jones, and our conference program director, Rich Williams, on the over 200 speakers and 170 sessions planned this year. It's going to be absolutely amazing. Also, if you register early during early bird registration, which ends on April 15th, you'll get free admission into our pre-conference workshops. After Nashville, we're going to be at the Copper Mountain Resort in Colorado on August 23rd, and then we'll be in Columbus, Ohio on November 3rd. I don't know what's going on in Columbus in Ohio, but we already got a ton of registrants for that. So I can see that people are, chomping at the bit in Ohio. So appreciate that. Anyway, we hope to see you there. Jennifer has the information there on your screen. So please, start registering. I'm also incredibly excited. I've been excited for weeks here on today's Fiber for Breakfast session. We're going to be discussing crowdsourced network performance data insights into customer experience and broadband funding opportunities. But before I formally introduce today's guests, I'd like to introduce Jennifer Brazil, who is going to walk us through some housekeeping items.
Thank you, Gary, and good morning to those who have joined us. I would like to again thank our sponsors of Fiber for Breakfast, including our platinum sponsor, Broadband.money, our gold sponsors, Jonard Tools, Millennium, and MyBundle.tv, and our silver sponsor, STL. I'm going to quickly go over a few logistical items. Please keep in mind, all participants are in listen mode only. To ask a question, please type it into the question box located within your control panel. We will host a Q&A session towards the end of the webinar. This presentation is being recorded and will be available to members on FBA's website within 24 hours. You can find the recording and all of our Fiber for Breakfast recordings in the Events tab under the Fiber for Breakfast drop-down option. And at the conclusion of the presentation, you'll be prompted to complete a brief feedback survey. We appreciate your input. I'll now pass it back to Gary to introduce our panelists and get us started.
Thanks, Jennifer, and good morning. I'm Gary Bolton, the President and CEO of the Fiber Broadband Association. Last week at the Fiber for Breakfast, the Fiber Broadband Association's conference leadership provided a quick preview on what to expect at Fiber Connect 22, and that's coming up in Nashville, June 12th to 15th. And it's shaping up. Today, we'll be speaking with Bryan Darr, the Vice President of Smart Communities at Ookla. As many of you know, I'm a huge fan of data and analytics, and Ookla is a very rich source of network performance data. Today's session is crowdsourced network performance data insights into customer experience and broadband funding opportunities. I can't tell you how much I've been looking forward to this session. Bryan is the Vice President of Smart Communities at Ookla. His focus is on bringing Ookla's vast network performance and coverage intelligence to the public sector and the telecommunications infrastructure industry. Bryan has spent most of his professional life in the wireless industry, beginning with a career in cellular as a sales rep for Cellular One of Memphis in 1985. After discovering his customers were having a difficult time traveling with their phones, he founded Mosaic in 1988, originally branded as American Roamer, and began developing consumer roaming guides. Soon, Mosaic was researching and designing mobile operator coverage maps, enabled them to market the reach of their mobile networks. In June 2018, Mosaic was acquired by Ookla, and Bryan serves on many industry committees during his career. He currently serves on CTIA's Smart Cities Steering Committee. So welcome, Bryan. And for audience, please type in your questions as we go, and I'll work them into our discussion at the Q&A at the end. With that, over to you, Bryan.
Gary, thank you so much for the opportunity to speak with everybody this morning. We've got quite a few slides to show. We're going to start out a little bit with some background on Ookla for those of you who might not be familiar with all of the different things that we do. Jennifer is, I think, going to advance our slides for us here. We are the global leader in mobile and broadband network intelligence. We have roughly 18 million consumer-initiated tests every day, and we just passed 40 billion about a month ago of total tests to date. All of our data is anonymized. We're very big on the privacy front. We do a lot of business in Europe and frankly around the world, and I have certainly wanted to get on board and ahead of that here in the United States, as California has already enacted quite a few of those laws. We have the most users, tests, data, and insight of this type of anybody in the world. Next, please. This is just a quick view of our global server network. We've got over 16,000 testing servers across the world, about 1,600 within the United States. And as you can see, we've got 10,000, more than 10,000 global hosts, different companies that host these servers for us. Next slide, please. We have really good working relationships with folks at NTIA, the FCC, and other major leadership groups around the world. Both NTIA used our data for their most recent national broadband map that they released last year. The FCC has just renewed their relationship with us just a few weeks ago and extended that as they're preparing to work on their new map. Next slide. So a little bit about the role for crowdsourced data and why it's so important. The sheer volume of it is just exponential relative to other efforts. You do get a consistency. When people try to go do their own collection, they typically end up getting a spike of data, and then it drops off. We have a loyal user base that consistently provides this information. The diversity of ways that people use the internet, a way to validate whether we're actually seeing service provisioned at a given level in a given area. And then of course the history. You've got a baseline of what you're looking at today. You can look back to see how far we've come. And as we move forward into the future, it's a way to measure that progress. The Broadband Data Act does very clearly state that the FCC is required to prioritize the consideration of data by data collection applications used by consumers. And this is really the way that most consumers are going to be able to let their feelings be known. Not a whole lot of people want to go out and do a lot of surveys. Next slide, please. How do we collect this data? We do get a lot of data from mobile devices. Yes, people take speed tests in browsers. We have desktop applications as well. But if people use a mobile device, then we get an extra bonus. We get extraordinarily granular GPS latitude and longitude information associated with where that test was taken. If you see only the bars on your phone, then you're testing your cellular network. If you see that Wi-Fi connection, then the vast majority of those tests are actually capturing a fixed network. And that allows us to see not only the mobile device and who it's subscribing to on the mobile side, but it does allow us to see who the fixed ISP is because we are seeing the entire trace route. Next slide, please. We have a lot of questions about latency associated with the Wi-Fi connection itself. Since we see the trace route, we can individually look at the different portions of it. And so we do actually remove tests before we aggregate them. Now, all the tests are on our raw data, but we do remove the tests before we aggregate into the numbers that we present publicly. Anything that has a too high of a latency on that first hop between a laptop and the Wi-Fi router or the mobile device and the Wi-Fi router. Next, please. So wanted to just provide a quick view of what latency looks like today across the various types of networks. Upper right-hand corner, all fixed networks, you can see that across the entire country, that's averaging about 14 milliseconds, with some level of variety here in the top providers. But this number does actually represent everyone. So it's a mix of DSL, cable, fiber, and these are the numbers that we see today. Down below there, the satellite networks, you can see the extraordinary difference between the low Earth orbit that Starlink has been rolling out relative to the more traditional providers at HughesNet and Viasat. And then, of course, on the left with the mobile providers, you can see that low 30s is about what they're averaging typically for the latency on their mobile networks. Next slide, please. This is a view into the aggregated data. This has gone through all of our methodology. So a lot of tests have been removed that didn't meet certain criteria, like the Wi-Fi connection that I mentioned before. There are other things that get filtered out as well, and we do account for users that are very heavy users versus those that are very light. And this is a way for our clients to be able, and for regulators and state broadband offices for that matter, to actually take a look at the trending over various geographic areas over a long period of time. The next slide, please, Jennifer, will actually show how we break out, the individual ISPs, and we can show what the test counts are. The user count really defines how many unique devices that we're seeing that represent all of those tests. And you get your download, your upload, and your latency numbers averaged for each one for whatever geographic area that you've searched on, whether that's a city or a county or a zip code or the entire country. Next slide, please. All right, Jennifer, I'm going to ask you to be on your toes here because we're going to go through quite a few slides quickly. We're going to show some layering of maps and the various types of crowdsourced data that we can use to help inform really what's out there. We're going to zoom in on a community called Black Forest, Colorado, right outside of Colorado Springs. It's got it's suburban, but part of it's forested. Where it's actually populated has got a density a bit higher than 150 people per square mile, because there is a lot of wooded area within it, as the name would imply. But if you'll go to the next slide, please, Jennifer, we'll start layering this information here. So all we've done is pull down the Form 477 data, the last reported information. I know there's new coming, but the last that's out there is December 2020. This just, for simplification, all the different flavors of DSL, we just rolled onto one layer. The next layer is going to show cable overlaid on top of that. We're not going to try and mix them. We're going to show the most modern technology on top. And the next layer is going to show the fiber on top of that that's claimed by the operators that have submitted this information to the FCC. You can see the municipal boundary in gray. So now we've got all of the different layers of technology that should be available. The next slide is now going to show the speed tests that we're seeing only on the fixed networks. We're going to talk about mobile in a minute, but this is just fixed. And so we're looking at 2021 speed tests. This is 12 months worth of fixed tests, and it's only a subset. It's only those tests that we can define with a very high granularity of GPS, very high accuracy. And so you can see here in blue, we've got areas in the lower left-hand corner of the map, southwest corner of the map, in the city of Colorado Springs. We're seeing a lot of very high speed rollout down there. That's got to be either fiber or at least very, very modern cable networks. But other areas where fiber was claimed in December 2020, we're not seeing that rollout. Is it an adoption issue? Is it under construction right now and just not completed? These are some of the questions that regulators and the state broadband offices are wrestling with. How do we reconcile these differences with what's been reported to the FCC? Next slide, please. Now we're going to take a look at the mobile networks. The other piece of information that we can collect in the background that's not consumer initiated. If someone has downloaded our app to an Android device and opted to allow us to see their location, we are anonymously capturing signal strength and quality readings in the background as they go about their daily lives. What you see here in green and blue is very strong signal. What you see in orange to red is a weaker signal. And the next slide is actually going to show where we have layered. The first slide was just Verizon. Now we put all of the 3 major national networks on here and combined them together. It's kind of messy, but we're now going to peel back on the next slide all of the poorer coverage where people are going to have difficulty inside. Oh, I apologize. I skipped one. We've now circled the areas here in this purple outline where we have populated areas where people have actually built homes and businesses, and we've got streets that need to be covered as well. And you can see that these areas are very poorly covered, yet there are people living, driving, and going to work in these areas. Next slide, please. All right, now we've pulled back the weaker coverage. And we can clearly see, where these areas are and where the networks are not covering them very strongly. And what you're going to need for both fixed and for wireless ultimately is fiber connectivity. The next slide, please, Jennifer, is going to show the speed tests on the mobile networks that we're experiencing in these areas. And you can see it's a mix of how dense this information is. But particularly on the left-hand side, you're going to see a lot of attempts to get a speed test. The red and yellow dots show where they're below 25 or below 100, and obviously struggling to get decent connectivity. The next slide is going to then show on top of that where we have detected towers, and you can clearly see the areas that are in need of infrastructure development. And so this is the wireless that we're looking at here. As I mentioned, this is all wireless, but we're going to leave these boundaries on here that we've drawn where the poor coverage is. And now we're going to flip to the next slide, which is going to overlay those same boundaries back to the fixed networks. And you can see in most of these areas that have been outlined, the connectivity is poor on both fixed and on mobile. You've got an opportunity to invest here where not only do you need connectivity directly to homes and businesses, but you also need connectivity to the wireless infrastructure that's going to have to be put in place to improve coverage for to these users. Next slide. So here, just a quick overview of a couple of ways that state broadband offices have been using our data. The state of Ohio hired an outside consulting firm called Reed Consulting. You see them referenced in the bottom right-hand corner. And they actually took all of our data for the entire state and then showed where this averaged out to be the varying speeds as the state's trying to understand, where the need for connectivity is the highest. You're going to have some tests within some of these even poor areas that might be higher, a bit higher than the average, but this is where consumers are having the most difficulty getting good connectivity to the internet. The next slide is going to show South Carolina. The South Carolina Broadband Office has actually published an atlas, county by county, of what level of technology is expected there. They've then overlaid that with Ookla speed test data and with demographic data. The map on the left actually shows not only the different speed tiers, but underneath that, where the speed tiers don't meet those FCC minimums, where the density of population then also can justify a higher level of infrastructure build. And they've broken this out for the entire state, county by county, and also developed a scorecard that you see at the bottom middle. Next slide. That's it for our slides today. Certainly want to thank you for the opportunity to present that, and I'll hand this back over to Gary.
Hey, thanks, Brian. You know, I just love these kind of discussions. Hey, Jennifer, send it back to that latency chart. And so one of the things, Brian, latency to me is, you know, that I think about that all day long. That's, you know, I just think that's the long pole in the tent now that we're, you know, delivering gigabit networks and 10 gig networks. It's really all going to be all about latency. And it's, you know, keep going back, Jennifer, till you'll see a bunch of charts on latency. The thing that I'm concerned about are, you know, the FCC had defined low latency as sub 100. Keep going back, Jennifer. Go way back to like near
Lots
the
of
beginning.
slides.
Yeah. But anyway, the FCC had defined it as 100 milliseconds, under 100 milliseconds. Right there, yeah. So I believe it needs to be under 20 milliseconds, and I'd like to get us down to at least sub 3 milliseconds. And so what you're saying is today, network providers can deliver 14 milliseconds on average.
On average, but that's a mix of all technologies, Gary. That's going to include the DSL, you know, and other older technologies.
And so, and so I think this is really important, because if we need to be able to get to, you know, say 3 milliseconds to be able to do VR and, you know, really be able to have the kind of experience we're going to need in the next several years. And mobile networks, you're showing where they are around, you know, 20 to 30?
Yeah, they're in the low 30s right now on average.
Low 30s. And then satellites are way up there, 700, 600, 700.
Yeah, there's a lot of variability here. What we commonly will see that the mobile networks sort of on the worst side of the performance. I mean, not outliers necessarily, but you know, in areas where they're having, you know, poorer latency on average, it tends to be in the 40s, you know, up close to 50. And we are seeing, you know, in some areas that they're getting down below 30, but it is averaging out in the low 30s nationwide.
So one of the things that you mentioned to me that kind of blew my mind is that you said that 80% of mobile traffic is over the fixed network. And, you know, and even when you said that, I'm like, I want to believe that, but I don't. So I was Googling and I found a number of different sources that backed up your claim. But that's an amazing number, right? And obviously, you know, I've worked on Wi-Fi offload in past years, and so I know technically how it works, right? As soon as you're in your house or your office or anywhere there's a Wi-Fi or any other thing that, you know, the first rule of wireless is get out of the air and into the ground to the first available spot. So mobile networks can be able to deliver these low latency if they're able to hop off the wireless network as quick as possible into fiber somewhere. Is that right?
Yes, that's true. You know, the more advanced, the new 5G networks that are coming out, edge computing, you know, moving connectivity and processing to the edge is going to have a big impact on lowering those latencies in areas where that is available. But there are going to be a lot of areas that are a long time from seeing that sort of thing. Only in very densely populated networks are we going to see that kind of capability, at least in the early days. And so, but mobile networks, absolutely, people are using those mobile devices more and more and more, but they're using them in their home, they're using them in their office, they're using them in the coffee shop or wherever they might be. And it is jumping off to that. The in-home connectivity is an important aspect and an important part of the user experience. And the users often negatively impact their own experience by putting that Wi-Fi router in a metal cabinet. They're trying to use, you know, the connection from too many rooms away or out in their backyard, and often will blame their provider. AT&T, Verizon, T-Mobile, or whoever that provider is, you know, their name is up there in the top of that device, and they're, to a certain extent, they're getting the reward or the blame, or a part of that for however that connection is made.
So I'm getting a ton of questions. I still have a lot of questions, but let me get to some of the audience questions. So the biggest question that they have today is, where can we obtain valid crowdsourced broadband service data? The most current funding opportunities allow applicants to cite crowdsourced data to support eligible location claims. So those people seeking grants, where do they get this crowdsourced data?
Well, we are a data provider. There's a number of places you can get crowdsourced data, but we do believe that we are the largest provider of that data. That is our business. Data is our business, and we provide the aggregated data through our portals, but the raw data allows our clients to go do, you know, their own analysis and concentrate on just the areas that they are most interested in. So there's people can reach out to me via email, whatever. I'd be happy to get them connected with other folks within our organization.
Fantastic. Can you comment on the status of servers that can test beyond 1 gigabit, as several service providers are looking at offering 2 gig and beyond?
Yeah, I can't go into the details of who we're testing with at this point, but I can tell you that just as of Monday, our leader in that part of the business development section said that we had been successfully testing 10 gigabit. We're seeing the numbers like high, 900 numbers which is exactly what you expect to see. You're not expecting to see exactly 10 because you've got some split and overhead there to contend with. But we're seeing, that approaching that true, I mean, actually 9.9 gigabits. It's pretty amazing.
So does Ookla have any plans to use layered speed test data with the forthcoming FCC maps? For example, if a WISP shows the exact propagation polygons in the new FCC maps, then Ookla overlays users of that WISP.
Correct.
Kind of like what you showed on your charts, right?
The FCC is using our data. Exactly how that's going to look in the map, it's difficult to really know. Because we're in the data business, we don't allow them to just release the raw data, into the wild, because that would sort of undercut our business model. But they will be releasing aggregated information. I'm quite confident of that. One of the interesting things, though, about because we're getting our data so real time, we update our portal every night. We're seeing new areas that are being expanded into that the federal government has no record of at this point, because there hasn't been an opportunity yet for those filings to take place through Form 477. So we're very much ahead of the game in terms of actually seeing real world consumer experiences, as the networks are being built out before they're even declared.
So on the first of all, our audience says, Bryan, great to hear your presentation. In the Black Forest example, where the 477 data shows that fiber speed tests are showing sub 25, might some of that be explained by folks subscribing to a low speed basic fiber package instead of an available faster package, and that comes from the South Dakota PUC?
Yeah, Jennifer, go on to one more slide. There we go. Perfect. No, back one, please. There we go. So what this is actually showing is layered data. And what we're seeing are actual consumer experiences. One of the points that we were trying to make here is that some of these areas are claimed as having fiber build out, but we're not seeing any evidence of it in some of these areas. And this is one of the things that the state broadband offices and the federal government, both NTIA and the FCC, are trying to reconcile. Why are these areas reported as fiber when we're seeing no evidence of it? This data is tiered and layered. So the very fastest speeds that we're seeing are on top. So everywhere you see a blue dot, there's probably a green dot or even a yellow dot underneath that, because there are going to be some tests from people who may be taking a test and are subscribing to a lower tier of service, or maybe they've taken a test when their network was experiencing some problems. And so we've layered it in a way to where the highest speed experienced in a given geographic block is actually the dot that appears on the top. So where you see a cluster of red dots in the Black Forest, in several places around the Black Forest area, what we're saying is we see no indication at all that anyone is accessing a higher speed. So it does raise the question, is it being offered? Does it actually exist there? Is it an adoption problem? If you see a very significant number of tests, it's difficult to imagine that absolutely no one has adopted it in the full 12 months after the reported period. That's highly unlikely that we wouldn't see a single test that exceeds 25 or perhaps 100 when fiber is actually being offered in the area. I don't have the individual boundary lines on here for the census blocks because it just was going to make the map too muddy. But these areas that you see in purple represent a multitude of different census blocks of varying sizes. I think we all know that census blocks, when you get into rural areas, can be extraordinarily large, and in areas where it's dense, it may literally be just a city block. So you have a varying level of sizes here, but they're all sort of bled together on this map, just for simplification.
So we got to wrap up here, Bryan. This is amazing information, and the big square is kind of let you know how bad the past mapping using census blocks didn't really work out very well for us. So what is your thought on with the new the Broadband Data Act and what the FCC is going to be delivering, CostQuest is going to be delivering to the FCC? Do you think that's going to change the game for us? We're going to get better visibility and we can make better decisions?
I do, but I think it's going to take quite a while. There's a lot. The FCC is under a great deal of pressure to get this map pushed out, in part because of the way the legislation is written. The state broadband offices aren't going to get that guaranteed $100 billion until the FCC has finished a map. Let's face it, the map itself will never be finished because it's always going to be changing, right? But the question is, at what point can the FCC plant a flag and say, here's our first crack, so that that money can start to flow and the state governments can actually get their broadband offices up and running, start handing out some grants in areas where they know, where it's obvious that infrastructure is needed, and then let the rest of the money flow out as the map is improved over time. There's a desire to get this map rolled out by maybe end of summer, early fall. Is that realistic? It's hard to say, but we know that the fabric map that they're ultimately going for, that is going to map connectivity at every parcel, and ultimately they want every building in the country, that's a long way from being realized. And so, hopefully that a level of understanding, a level of visibility into broadband connectivity can get rolled out into a map so that these funds can start to flow.
Well, Bryan, thank you so much. What I love about Ookla data, it's not what people are promising, it's what subscribers are actually experiencing. So you can see what it is they're getting. So I really learned so much every time I talk to you. So thank you so much again, Bryan. And we really appreciate what you and Ookla are doing for our industry.
Thank you,
and
Gary.
I know there's a lot of questions here. People couldn't see the graphs that well. So send a note to Jennifer and she'll send you the charts if you're okay with that, Bryan.
Certainly, happy to answer whatever questions we can. And you can reach out to me via email, Bryan with a Y.Darr, D-A-R-R, @ookla.com.
All right, well, thanks for joining us today. I look forward to getting back together next Wednesday. We're going to be discussing the terabit edge with my friend and former colleague, Steve Alexander, who's the CTO at Sienna. And he's going to discuss how the terabit edge will be one of the key enablers delivering the high bandwidth, low latency services needed for our long sought for work, learn, play from anywhere digital experience. So you're not going to want to miss that. So we'll see you next Wednesday. Bye, everybody.
Thank you.